This is the NavBlade Senior Design Project. In this project, we were tasked with designing a lifting device for the CH53E main rotor blade. Currently, multiple artisans are required to pick up and rotate the blade 90 degrees manually before installing the blade clamp. Our ultimate goal is to make this process easier. Our objective is to design and manufacture a lifting device for the CH53E main rotor blade that can be installed on the blade while it is in the transportation cart and then rotate the blade 90 degrees for the installation on the helicopter. The reverse sequence will be required for removing the blade from the aircraft. For the project requirements, the prototype must operate with a safety factor of 5, perform with a load of 2 times the safe working load, as well as the main rotor blade weight of 371 pounds. It has to be capable of rotating the blade 90 degrees, and it has to hold the blade in a stable manner. This is the design of our lifting device, as well as an FEA analysis on critical points. On the right two pictures, you can see a representation of the blade in the horizontal position on top and the vertical position on the bottom. The straps are 5 feet 6 inches apart. For the stability, when the blade is in a state where it is tilted 12.5 degrees above the horizontal with the leading edge facing down, it takes 33 mph winds to tip the blade out of the straps. The gearbox operates with a 5-to-1 gear ratio. To turn the blade from horizontal to vertical, or vice versa, 12 steering wheel turns are needed. The steering wheel takes 5.2 inch-pounds of torque to turn. As seen in the FEA analysis to the left, the maximum stress is located at the end of the ribs with 43 megapascals. This has a safety factor of 5.76, which meets our safety factor requirement of 5. The total assembly weight is 250 pounds. To test the lifting device, a 2-ton engine hoist was used to hold the assembly and the weight. For the weight, 10 10-foot directional drilling rods, as seen in the bottom right picture, weighing 80 pounds per rod, were used to simulate around 800 pounds in the straps. This is 2 times the safe working load. The picture to the left shows the lifting device safely holding the 800-pound load. To test the rotation, the bundled drilling rods were rotated clockwise and counterclockwise. The rods rotated easily and no slipping occurred while rotating the weight. In conclusion, the lifting device rotates the proof load clockwise and counterclockwise with no slipping of the straps on the rollers. The wheels can be turned with 5.2 inch-pounds of torque, which is reasonable for operation. The prototype operated properly with a proof load of 800 pounds. Most parts on the assembly can be maintained individually. The prototype cost $2,801.86, which is under our given budget of $3,000. Here are some improvements that can be made. An automatic lifting device can be installed to prevent any unwanted load shifting. The lifting device weight could be reduced by using steel tubes instead of solid stock. Casters could be attached to make the transportation of the lifting device easier. An easier gearbox installation method can be designed. Here are the references that we used for the creation of this presentation.